We are continuing with logic minimization. We have done the Karnaugh Maps. We are still continuing with Karnaugh Maps with the two variable maps, covering the main concepts, covering the definitions, and why Karnaugh Map is good. And then we did some examples using three variable Karnaugh maps. In three variable Karnaugh maps, we kind of extended our definition of adjacency. And we're going to continue doing that, even going to five variable maps. So we keep extending the definition of physical adjacency. Boolean adjacency remains the same thing. So what I'm going to do now is go into four variable Karnaugh maps, and for the four variable Karnaugh maps, we do examples and we do more, like I said, more definitions of how the physical adjacency is defined. All right, let's start with this. This is a four variable map, and once again notice that the columns are 0, 0, 0, 1, 1, 1, 1, 0 instead of 1, 0, 1, 1, again for the reason of adjacency. And I do the same thing with the rows, and then again you see that 0, 0, 0, 1, 1, 1, 1, 0. Let's go over the numbering. The numbering goes 0, 1, see, the numbering goes 0, this is red, okay. The numbering goes 0, 1, then 2, 3. So when you reach the third column, you skip it, and then you come back to it. When you get to the third row, you skip it, you come back to it. Okay, this is considering that A is the most significant bit, considering the numerical values of the min terms, and then the D variable is the least significant bit that form the 4-bit numerical value of the min term. And therefore this is min term number 9. Min term number 9 is this, and this is A, B bar, C bar, D. Okay, just doing a quick review of what we have already seen. And now let's do the adjacency. We have already shown you that these four are adjacent. We have already shown you that these two are adjacent. Yeah, let's do this. These two are adjacent. And now I'm showing you that the four on the corners are also adjacent. Because before I showed you, I said, well, this is like a circular paper. So when you look at the back of it, then you see that these sides are adjacent. Now I'm saying it's really not a circle. It's more of a spherical adjacency, where the four corners are next to each other if you go back and look at the back of the Karnaugh map. And so one very nice way of representing this is as such, and notice that 0, 0, 0, 0, which is this. Okay, I hate to destroy this, but then this is 0, 0, 0, 0. 0, 0, 1, 0. 0, 0, 1, 0 is this. So notice how adjacent they are. And 1, 0, 1, 0, which is 1, 0, 1, 0 is this one lower, this one here. They are all shown by the color. And then finally the upper dark blue 1, 0, 0, 0. These are all adjacent. Okay, so this really covers all the adjacencies in the four variable maps, and so you also see other things that we have already seen before, that they are adjacent as well. All right, so okay, for example, see, these two are adjacent. these two are adjacent. Okay, all around the sides are adjacent, and so that's really pretty and colorful. Anyway, yeah. So this is 4 variable map, and we're going to be doing examples of 4 variable maps. Okay, again, what I do is I start with the truth table, and later on we say, well, we have done enough truth tables, so let's skip the truth table part and directly go to the Karnaugh map. This is a 4 variable truth table, the one on the right, and it has all these ones, and the ones I'm also showing them over here on the left. So 0 0 0 0 before doing this. This is this 0 0 1 0 0 0 1 0 is no 0 0 0 1. 0 0 0 1 is this. You can either do this or go by the numbers. Once again, the numbers go like this. Okay, this is 0 1 2 3. Go skip the row, come back to it. 4 5 6 7. Skip the column. 8 9 10 11, and then 12 13 14 15. Okay, so where do I have ones? In location 0, in location 1, and in location 5, for example, there is a 1 that you are seeing, the 1 there. All right, let's try to minimize this function. Minimizing this function, I have these 4 that are prime implicants, okay? And then I have these 4 that are also prime implicant. Why are they prime implicant? Because why are they prime implicants? Because there is no other implicant completely covering these, so they are called prime implicants. Okay. Once again, there are too many implicants to list each one of them. For example, this is an implicant, this is an implicant, this is an implicant, this is an implicant. So implicants, I'm not listing them. I start with prime implicants. Okay, for now, don't worry about them saying essential prime implicants. And how about these? Okay, now I have 4 on this side, 4 on this side. So if I go back and look at this thing over here, I see that all these 4 are adjacent. Now, all these 8 are adjacent, and therefore this is this, this is this, this is this. Okay, let's see. After we decide that these are prime implicants, again, they are prime implicants because there are no other implicants covering them completely. For example, look, you might want to look at this one here. Well, see, this is also a prime implicant, okay? And so this is also a prime implicant. What else? Do I have any more prime implicants? No, I don't. Okay. After that, I mark the essential prime implicants. Okay. Essential. The one on the sides. Let's see. The one on the sides. Okay. Because of this, this is essential. Okay. Also, because of this, this is essential. Why is it essential? Because this one, the 2 ones that I put an asterisk on, there are no other maps that completely, there are no other maps that cover this particular min term, and therefore this qualifies this map as an essential, and therefore you are seeing B bar is an essential. I list it. How about the blue one? Well, the blue one, uh, the the blue one, the one on the right, this that does not qualify the blue one for it being essential. The one on the left, that does not qualify that for being essential. Why? Because that particular one is covered by the black one that I just put in there. It is covered by the 8 ones that are already there, and that's it. So again, it is covered by several prime implicants, and therefore this particular one cannot make this an essential. How about the one next to it? This one here? Well, again, this one, the black one that I just put there, that covers it. And also the blue one covers it. So that one cannot qualify the blue one for being essential. How about this one? Now look at this one. This particular one is not covered by any other prime implicant, and therefore this particular one makes the blue map an essential prime implicant, and therefore I listed which is CD. Okay, so I'm done with these. Let's do this, and then do I have any more essentials? Let's look. Let's look at this upper left 4. This one is covered by what? By the pink one on the sides. Okay, so that one cannot make the map in question an essential. So let's forget about this. How about the one below? Well, the one below is covered by the black one that I show, is covered by this one that I'm talking about, is also covered by the pink one on the sides, and therefore there are too many people covering it, so that can't make that an essential. How about the one down below? The black one is covering it, which is a prime implicant, and so the one below this is not qualifying the map I'm talking about as an essential either. Now let's look at the one on the top. Okay, this one over here. Well, you see that nobody else covers that. Okay, no other prime implicant covers it. And therefore, that one alone is enough to make my A bar, C bar map an essential one. And therefore, I write by essential, and I'm done with the essentials. Now, the thing to do next is, okay, now that I've done the essentials, let's go back and see if there are any min terms that are not covered. Well, the pink one covers these 4 and these 4. The blue one covers these 4. Okay, and the upper left hand one covers this, and this. Okay, so several things. I have covered all my min terms, so I don't need anything anymore. Okay, what am I left with? I have a prime implicant that I haven't used, that black one. Fine. I don't really need it because I don't have any uncovered min terms, and therefore the black one just remains a prime implicant that is not used because all the essentials have completely covered all my min terms. All right, we're going to be doing more examples. Let's look at this particular example. This is what we are starting with, and okay, let's, without looking at down below, the maps down below, let's look at the map on top, okay? I have, this is a prime implicant. Why? Because, look, nothing else completely covers it, okay? Nothing else completely covers it, and therefore I mark this as a prime implicant. All right, I'm marking all my prime implicants first. And how about this? This is also a prime implicant because nothing else completely covers it. Okay. This is not a prime implicant. Why? Because the one outside, the brown one outside of it completely covers it, obviously. Therefore, the one inside is not a prime implicant, so I just remove it. Let's look at more prime implicants. Is this a prime implicant? Let's use some colors. Okay. Is this a prime implicant? Okay. Yes, it is, because nothing else completely covers it. So, yes, this is prime implicant. How about this? Is this a prime implicant? Again, nothing else completely covers it, and therefore this is also a prime implicant. How about this? Is this a prime implicant? Yes, this is a prime implicant as well. Okay, so what I did so far is I identified all my prime implicants. The next step is to go and do the essentials. Okay, so the first step is prime implicants. Now, once again, you don't really need to list all the implicants. There are just too many of them. Okay, and for example, this is an implicant. Let me do this in light blue. See, this is an implicant. And why this implicant is not a prime implicant? Because the dark blue completely covers it. That means the light blue doesn't have anything new in addition to what the dark blue is giving me. Okay? It's completely subset of the dark blue, and therefore it doesn't cover. It's not a prime implicant. All right. Now, let's look at this, and now let's identify the essentials. All right. For the essentials, look at, let me show you one more prime implicant, which is extremely important, which I was about to forget, and that is this is a prime implicant. Okay? This is a prime implicant. Why? Because true, the upper one is covered by the brown one, the lower one is covered by the red one, but then nothing completely covers this, and therefore this too is a prime implicant. Okay? Let me make sure I'm not missing anything. No, I'm not missing anything. So let's continue with selection of essential prime implicants. All right, is the dark blue an essential prime implicant? No, it's not, because all the ones that is covering are covered by other prime implicants as well. Okay? All the ones are covered by other prime implicants as well. How about the yellow one? Well, same thing with the yellow one. It covers two ones, and then the green covers one of the ones. The blue covers the light blue, or the not very light blue, but it covers the other one of it. But then there are no ones not covered by any other prime implicant. Okay, let's not beat around the bush. Let's go down to the point. How about the blue one? The blue one, let's start from the left. There is a one that is covered by the brown one. There is another one covered by the brown one. This one is not covered by anything else, and then this is enough to make this an essential prime implicant, and therefore I put an asterisk here, and then I say, well, this is an essential. Okay, that's enough. I don't need to continue. Once I find one, that's good enough. And it turns out that this is the only one anyway. Let's go on to the brown one. It has 4 ones there, and only one of them this one over here is not covered by any other prime implicant, but that's enough to make that brown one essential as well. Okay, let's look. Do I have any other essentials? Okay, no, I don't. And therefore, what I decide is I have to write the term A bar, C bar, as well as C bar D. Once I write these, C bar D gives me these four. Okay, midterm wise, A bar C bar gives me these four. Two of them repeated. I have exhausted all my essentials. These are essentials. This is essential. The blue one is essential. Okay, this is essential. This is essential. Okay, I've exhausted all my essentials. Now that I've exhausted all my essentials, do I have any more min terms left? Oh yeah, I have 3 of them left that are not covered yet. Okay, so what I do is I go to the next step. I say, let's pick prime implicants that cover the most number of uncovered min terms. 3 of them are there. And I have the red one that covers 2 of the uncovered min terms. I have the green one that covers another 2 of the uncovered min terms. Okay, it's essential. Sorry. See, the red one, this one, covers the 2 on the lower left and the lower right, which are not covered by any other map. So I say, well, why not choose the red one? If I choose the red one, then there will be 1 left. So let's choose the red one anyway, okay? And therefore, I decide choosing the red one. This is the red one, okay? So I choose the red one. I'm also choosing the red one here. Okay, which is this. Then I'm left with only one. Now, if I choose the red one, I put a check mark next to these 2, and then I say, well, I only have 1 left. Now that I have 1 left, I have the choice of the yellow one or the choice of the green one. Okay, what it means is either one is fine. So you're seeing the map on the right, all the way down on the right, and the map all the way down on the left. Both of them are choosing the red one, but then this one can be covered either by the one above it or with the one below it. So these are 2 good implementations, okay, so far. What if instead of saying that, okay, I choose the red one, which covers 2 uncovered min terms, what if I had said, let's go back to the original map, what if I had said, let's choose the green one, because that too covers 2 uncovered min terms, this one and this one, that are not covered by the essentials. Okay? So that's as good. So let's pick this one. If I pick this one, that means I haven't chosen the red one. Okay? That means I haven't chosen the red one. That covers these 2 here. Okay? Which means this. if I do this now, still I have one that is not covered, and this one is this one over here. That one can be covered either by the dark blue one, which is this, okay, or it can be covered by the red one. Okay, well, it being covered by the red one, I've already shown you on this side anyway, and therefore the right hand side solution is whether you start with the red one or the green one and you take the other one, that is the correct solution. What do I have? I have three different solutions for this. All of them are good. See, all of them have 4 terms, 2 of them 2 variable terms, 2 of them 3 variable terms. They are different, but they are all the same, and they realize this function completely. Okay? When you go from having essential prime implicants, and then you go into choosing prime implicants, which is the case here, unlike this one over here, that the essentials alone could cover the whole thing. This one, the function realization is unique. This one is not unique, because you go into prime implicants and then there may be choices, which means that the function is not going to be unique. All right, let's consider this example. This is another example of 4 variable maps, and look at the 4. Now you're going in the back of the map, or those 4 dots that we showed at the beginning. These are adjacent, and therefore this is A bar, D bar. Okay, let's see what else we have here. We have this one. We have this one. Okay, do I have any more prime implicants? Yes, I do. Here, this is also a prime implicant. Okay, do I have any more prime implicant? No, I don't have any more prime implicants. Now let's go for the essentials. The 4 corner one is definitely essential because of this, because of this, because of this. Not because of the upper right hand side, because the black one is also covering it. Okay, but then 1 is enough. If I have 1 mean term that qualifies this as an essential, that's good enough. So the map B bar D bar is essential, and I use it. All right. What else I have? Let's look at this one. This is again one that can give me 2 choices. This one is essential. Okay, because this one that I just put an asterisk on is only covered by the brown one. And therefore, I write this A, B, C. A, B, D. Okay. Let's check mark those that have already been covered. This is done. This is done. This is taken care of. This is taken care of. These 2 are taken care of. I have 1 left. I have 1 left, and that one can either be covered by the black one that I'm showing, or it can be covered by the green one that I have decided before that I want to use this, and this one is this. A, C bar, D. if you had decided that you don't want this for any reason, and instead you wanted this one, which I'm making it blue now, which is a prime implicant, which also covers the only uncovered mean term up to this point here, you would do A, B bar, C bar. A, B bar, C bar. Okay? So your solution is the following. W is A, B, D, ORed with B bar, D bar, ORed with either this one, which is A, C bar, D, A, C bar, D, which is the solution I have there, or this one, which is A, B bar, C bar. Okay? All right. That is with 4 variable maps. And we did several examples. Again, the key thing is start with essentials, write them all, and then choose the prime implicants that cover the most uncovered mean terms. That is, if essentials do not take care of everything. What we do next is do higher order maps.